All right, in this video, we are talking about trig functions of any angles. And in this particular one, we're just going to be dealing with degrees only. And then in another video, we're going to focus on radians to split them up a little. So trig function of any angle. So let's start with this first. In order to do that, we say let theta be any angle in standard position. So we're going to talk about that in a second. Standard position, and then let P, some point x comma y, be the point on terminal side of theta. If R is square root of x squared plus y squared, if that R is the distance from the origin to this point P, then we can easily find out what the six trig functions are. So let's go ahead and kind of like break this up a little bit, talk about the things that are being in there. What is standard position? What is the terminal side? What is this R? What is this point P? So let's take a look. So it's saying that, let's just say standard position means you have an angle that starts on your positive x axis, which is also known as your initial side. Initial side. And then it's saying let P be a point on the terminal side of theta. Well, what is the terminal side? Well, terminal side is what opens up to the angle theta. So for example, like if I have this angle that is opening up, right? This is opening up, and let's say this right here is, theta. This is the terminal side that it's opening up to. This is our terminal side, the side that is opening up to make the angle with your initial side. So this right here is a terminal side. Terminal side. And then it's saying let there be a point P. So let's just call this point P x comma y. So this is some random angle, right? Some random angle. And then can we find out the trig ratios for this random angle? Well, we can 100% find out, because like if I think about it logically, right? If I have this point P that is away from the origin, x comma y, I can kind of create a right triangle with it. So think about it this way. P is x comma y. That means it has moved away from 0 to x distance away. So like I can actually create this right triangle over here, because this right here has moved x distance away from the origin. This right here has moved y distance away from the origin on the y-axis. So I clearly know what the x is in, x is some units away from the origin, y is some units away for the height. And then it's saying then R is the hypotenuse. R is the hypotenuse, which we will, we can use Pythagorean theorem to find it. So R can be found just doing square root of x squared plus y squared. So in this case, we can see theta is lying in the first quadrant. So theta is in quadrant 1. And that's not the only time, we can do it. We can always see the same situation happen in different quadrants. So for example, just to throw another one out there, standard position, positive x-axis, again labeling this initial side, and let's just say it is going over here. So let's just say the point P took us like right over here, right? It took us right over here. So this is P is x comma y, x comma y. And then I know, well, let me actually label this also. So this is our terminal side over here, just to kind of like keep it consistent and showing which is the initial, which is the terminal side. So terminal side. Well, I know I can create a right triangle with this. I can create a right triangle with this because I know that this, in order for P to be there, it has traveled this many units of x away from the origin. So there's the x, right? It has traveled that many units in the left side, and in order for it to be in the y position, it has traveled this many units down here to be the y. And there's the right triangle. And so we can easily use trig to find all the 6 trig ratios. And one of the things to keep in mind with this is, well, think about it this way. This is sitting in the third quadrant. So technically, that x has a negative value to it, and then y also has a negative value to it, which we'll talk about that in a little bit more at an example when we take a look at it to see why paying attention to this point P and where it's sitting affects the answers you're going to write. So kind of just to generalize this, by taking a look at the first diagram that was sitting in the first quadrant, well, I can say the sign of that is just going to be, opposite of theta is y over r. And cosine is going to be x over r. Tangent is just y over x. And then these are just reciprocal properties, so r over y, r over x, x over y. So that's kind of like the general case for it. So standard position is kind of like, it starts on the positive side of your x-axis. That's where your initial side always is. And terminal side is the one that opens up to create your angle theta. All right, so let's take a look at an example. So what do we have over here? So evaluating trig functions with let point P -3, -5 be the point on the terminal side of theta. Find each of the 6 trig functions. All right, so -3, -5 is sitting in the third quadrant. So let's kind of put that there. 1, 2, 3. So that means I'm going to take this from the origin, right? So that means it's actually traveling 3 units to the left. It's traveling 3 units to the left. 3 units to the left. It's right here, right? 3 units to the left. And then it's going down 5 units till here. So this is our point P. This is our point P, and it kind of started off. This is the initial side, so now I can kind of create this little angle. So like this is, it did this rotation to kind of come from the initial side to the terminal side, where P is -3, -5. So I have a right triangle that I can easily use to find out what R is first, and then I can find out the six trig ratio. So let's do the R first. So this is going to be R is equal to, so remember this was, we traveled 3 this direction, and this was 5. We went down, so the height, or whatever you want to call it, is 5, and it's 3 units wide, or the base is 3. So this is going to be 3 squared plus 5 squared. So that's R is equal to going to be 9 plus 25. 9 plus 25. So R is equal to square root of 34. And it doesn't look like I can rationalize this. 34, no. So we officially know R is square root of 34. So let me kind of just replace it to say this is 34. Okay. And then we can do our 6 trig ratios. So let's see, sine of theta is going to be, what is sine of theta going to be? That's going to be, well, y over r, right? So y over r is going to be 5 over root 34. So this is where you have to be careful that I was mentioning earlier. You have to pay attention to what quadrant your point is. Well, in this case, it's sitting in the third quadrant. Well, the value of sine is negative, or sorry, the value of this 5 is negative, right? It was -5, -3. So you have to make sure you put this as a -5. Do not forget about the negative sign. So cosine of theta is going to be -3 over 34. Tangent of theta is going to be y over x. So -5 over -3, which is 5/3. And then we can kind of just take the reciprocal properties. So cosecant is 34 over -5. Secant of theta is going to be is going to be square root of 34 over -3. And then cotangent of theta is just 3 over 5. So that's how we can find out trig ratios for any given angle given a point. All right, so the next thing is if you've been kind of paying attention to, like, there's this right triangle that is getting formed, right? This right triangle is getting formed. So let's talk about some of the angles that we're kind of seeing in there. So one of the things is this reference angle. So over here, like if, let me just kind of go back over here and like kind of take this right triangle out. Like this is what this right triangle looks like. Right. So technically, this angle is not the same as this blue angle over here, right? It's not the same as this because clearly that is definitely not that small little angle hiding in the right triangle, but that little angle is what we call reference angle. It's what we call a reference angle. So we have a definition of a reference angle. So let theta be any non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive acute angle. We'll call it theta prime. We'll call it theta prime, formed by the terminal side of theta and the x-axis. This is the key. Its reference angle is the positive acute angle, theta prime, that is formed by the terminal side and the x-axis. So that is the definition of a reference angle. And if you're wondering, like, what the heck does that even mean? Well, let's dive into it, see what it means. So it's saying let theta. So let's just let theta be any non-acute angle in standard position. So let's just make an angle that is sitting in the second quadrant. So let's just put it in second quadrant. So this angle right here is theta. And it's saying that this angle has a reference angle that is going to be a positive acute angle theta prime. So over here, right here, this angle actually is the reference angle that is being formed by the terminal side and the x-axis. That is being formed, again, terminal side and the x-axis. That's something you're going to have to remember to make sure that you do not kind of like make the mistake where the reference angle comes from. So with that, how do we find the reference angle? Well, let's think about it. So if our theta is bigger than 90 but less than 180, how can I find out what theta prime is? Then this reference angle theta prime is 180 minus theta. That will always give us a reference angle for something that is sitting in the second quadrant, right? So then let's take a look at a couple other cases. So let's take a case when we have something that is sitting in the third quadrant. So here is theta. This right here is theta. Well, that definitely cannot be part of the right triangle over there or the reference angle over there. The reference angle, again, is the terminal side and the x-axis. It is always the x-axis. So right here is the reference angle. So over here we can say is if theta is bigger than 180 but less than 270, then the reference angle is equal to theta minus 180. Theta minus 180. We can easily find out what the reference angle is if it is sitting in the third quadrant. Right, so if you have kind of been following the trend, clearly the last example is the fourth quadrant situation. What happens, if you have an angle sitting in the fourth quadrant? Well, that is this big angle right here, which is theta. That means the reference angle for it is over here, this acute angle right here. All right, so this is going to be, let's see here. So how do we find out that? Well, if theta is bigger than 270, less than 360, then our reference angle, or this theta prime, equals 360 minus theta. So those are the rules we're going to use to kind of find reference angles. And then we'll talk about why reference angles can be super helpful in dealing with trig, and when we're evaluating, trig functions, and which we'll talk about that as we take a look at these examples over here. So we are being asked to find the reference angles. There's three, and let me change this one over here. Let's change this to 240. Let's change this to 240. Okay, so here we go. So let's draw these in. One of the nice things to do, like when dealing with them, is kind of like always draw where the angle, is going to be, and then go from there. And then think about the rules that exist to finding these angles. So here we go. So 150 degrees. Well, if I think about 150 degrees, well, here's the initial side. 150 is clearly bigger than 90, less than 180, so it's going to be somewhere in the second quadrant over here. So here it is. This is 150 degrees. And its reference angle is going to be this. This is the reference angle, theta. This is what we're trying to find, theta prime. So then we can think about it this way. In order to find this, all I got to do is take 180, subtract it from 150, and I will have my answer that this is actually 30 degrees. So the reference angle to 150 is 30 degrees. All right, so let's keep going over here. Let's take a look at 315 degrees. So 315 degrees is sitting clearly in the fourth quadrant, because we know it's less than 360 but bigger than 270. So it is right over here, somewhere over here at least. So this is 315 degrees, and its reference angle is right over here. So theta prime. So over here we can say theta prime is going to be 360 degrees minus 315, which is going to be, what is this, 45 degrees. 45 degrees is the reference angle. So what about a negative angle? What about a negative angle? So if I have a negative angle, again, I'm still starting on the positive x-axis. Always start there. But if you've been seeing stuff about this, if you know like how angles work, if it's positive, always counterclockwise. If it's negative, it opens clockwise. So clearly this is going to go somewhere over here. Well, this is 90, 180, and it's got to be less than 270, so somewhere over here. So it's sitting in the second quadrant. It's sitting in the second quadrant, so it is going to be this. So let's say this is the negative 240. Whoops. 240 degrees. So this is going to be the reference angle right over here. It is always remember the terminal side and the x-axis every single time. So theta, this is going to be, so it's sitting in the second quadrant, so clearly I'm going to be doing something to do with 180 degrees for this. So this is going to be what over here? This is going to be 60 degrees. So theta prime is 60 degrees. 60 degrees. So in this case, I'm going to be doing negative 240 plus 180. So there it is, 60 degrees. So we have just found, ways we can find our reference angles. And then what are they useful for? What are reference angles useful for? Well, they're useful for when we are trying to evaluate trig functions. So let's say, for example, you end up seeing a problem like this, where it is going like, you know, maybe I should have used the same angles, but you know what? We'll just get more practice in. We'll get more practice in finding these reference angles. So using reference angles to evaluate trig functions. So how exactly can we do that? Well, if you have a problem like, that's telling you, sine of 135, go find sine of 135, go find what is the cotangent of 210, or what is the sine of negative 150 degrees. Well, you're probably thinking, oh my God, this is like a lot of work. Like I don't know what sine of 135 is. I don't know what cotangent of 210 is. I have no idea what sine of negative 150 is. What we can do is we can use the reference angles to help us evaluate that. So step number one is just to get more practice, and let's kind of like redraw these reference angles, and then we'll see how we can easily find out what the trig function is for 135, for 210, or for 1 or negative 150. So just to kind of like practice drawing this again. So 135 is going to be sitting over here in the second quadrant. So this is 135. So by doing the math, this tells me that this is 45 degrees. And now how does that help me? Well, if you don't know anything about what sine of 35 is, or 135 is, well, we can now say that sine of 135 is actually equal to sine of 45 degrees. So as long as we know what sine of 45 degrees is, it's going to be the same. And it is going to be square root of, so if I know sine of 45 is square root of 2 over 2. Square root of 2 over 2. And one of the other things, again, you have to keep in mind when you are doing these, always pay attention to what quadrants these angles are sitting in. So sine is sitting in the second quadrant. Sine is positive in the second quadrant. So the answer is just going to be square root of 2 over 2. So that's how we can easily find out, what these answers are going to be. So I can say this is root 2 over 2. Okay, in our next example, what do we got? We got cosine of 210 over here. So let's see. So cosine of 210. So let's first draw it in. So let's draw this in right over here. So 210 is going to be like the 90, 80, so somewhere right over here. So cosine of 210 degrees, which is definitely a really, really weird approximation of 210 over there. So we know this is 210. And then we know this is going to be the reference angle right over here. So this is going to be right over here. So then I can just say, well, this is, what is this going to be? 210. So this is 30 degrees over here. So this is 30 degrees. So cosine of, so I can say that, whoops, not sine. This is going to be that cosine of 210 is the same as cosine of 30 degrees. So cosine of 30 degrees is, we know cosine of 30 degrees is square root of 3 over 2. That's the cosine of 30. So that is going to be the same as 210. So square root of 3 over 2, except we have to be careful. This is sitting in the third quadrant, and cosine actually is negative over here. It is negative over here. So it is going to be negative root 3 over 2. So that's kind of like how we can evaluate these trig functions. So the last one, sine of 150 degrees. Can I find out what the sine of 150 is? So this is going to be somewhere like right over here. Somewhere right over here. Going clockwise, so this is negative 150 degrees. So the reference angle is right over here. So this is going to be 30 degrees, 30 degrees, so reference is 30, so sine of 30, sine of 30. Well, again, I can kind of say that, sine of negative 150 is equal to sine of 30. Well, I know sine of 30 is 1/2. I know it is 1/2. So I can say this is equal to 1/2. But again, keeping in mind, this is sitting in the third quadrant where everything is negative. So this is actually going to be negative 1/2. So that is how we can use reference angles to evaluate trig functions. And that is it. That is it for this.